Hi everyone, and welcome to the Safety Artisan, where you will find professional, pragmatic, and impartial advice, whether you want to know how safety is done or how to do it. Hopefully you'll find today's session helpful. It's the 21st of September 2019 as I record this, and welcome to the show. So let's get started. What we're going to talk about today is system safety concepts. Okay, what does it all mean? And we need to ask this question because it's not obvious, as we will see. So if we look at a dictionary definition of the word safe, we see it's an adjective: to be protected from or not exposed to danger or risk, not likely to be harmed or lost. Okay, that's great. And there are synonyms: so protect, shield, shelter, guard, defend, keep out of harm's way. All right. So that's great. They're all good words. I think we all know what we're talking about, but as a definition, it's too imprecise. We can't objectively say whether we have achieved safety, whether we've made something safe or not. What we need is a better definition, a more practical definition. So here we go. I've taken something from an old UK defence standard. Forget about which standard, that's not important. It's just that we're using a consistent set of definitions to work through basic safety concepts. And it's important to do that because different standards come from different legal systems. They have different philosophies. So if you start mixing standards and different concepts together, then it doesn't always work out. Okay, so whatever you do, be consistent. That's the key point. Anyway, we're going to use these set of definitions from the UK Defence Standard because they are consistent and they're well thought through. So, in this standard, safe means risk has been demonstrated to have been reduced to a level that is ALARP and broadly acceptable or tolerable, and relevant prescriptive safety requirements have been met for a system in a given application in a given operating environment. Okay, so let's unpack that. So we start off with risk. We need to manage risk. We need to show that risk has been reduced to an acceptable level as required perhaps by law or regulation or a standard or just good practice in a particular industry. Whatever it is, we need to show that risk of harm to people has been reduced. And not just any old reduction, but we need to show that it's been reduced to a particular level. Now, in this standard, there are two tests for that, and they're both objective tests. The first one says ALARP means as low as reasonably practicable. And basically, it's saying, have all reasonably practicable risk reduction measures been taken? Okay, so that's one test. And the second test is a bit simpler, and it's basically saying, have we reduced the absolute level of risk to something that is tolerable or acceptable? Now, don't worry too much about precisely what these things mean. The purpose for today is to say we've got an objective test to say we've done enough, and that's what we need. So that's dealt with risk. It was easy, wasn't it? Let's move on to safety requirements. So if a requirement is relevant, then we need to apply it. And if it's prescriptive, if it says you must do this or you must do that, then we need to meet it. And that's very important. And there are two separate parts to this requirement for safe. We've got to meet requirements and we've got to manage risk. And we can't use one as an excuse for not doing the other. So just because we've reduced risk to ALARP and tolerable or acceptable doesn't mean that we can ignore safety requirements or vice versa. So far, so good. Okay, so those are the two key things that we've got to do, but that's not actually quite enough to get us there, because we've got to define what we're doing it with and to, and in what context. So first of all, what are we doing it to? Well, we're reducing the risk of a system, and the system might be a physical thing, it might be a vehicle, you know, an aeroplane or a ship or a submarine, it might be a car or a truck, or it might be something a bit more intangible. It might be a computer program that we're using to determine, make a decision or make a determination that affects the safety of human beings. Maybe a medical diagnosis system, or we're processing some scripts or prescriptions for medicine, and we've got to get it right, otherwise we could poison somebody. So whether it's a tangible or an intangible system, we need to define it. And that's not as easy as it sounds, because, you know, if we're applying system safety, we're doing it because we have a complex system. You know, it's not a toaster. It's something a bit more challenging than that. And so defining the system carefully and precisely is really important and really helpful for getting it right later on. So we've defined what our system is, our thing or our service, our system. Well, what are we doing with it? What are we applying it to? What are we using it for? Now, just to illustrate that no standard is perfect, for some unknown reason, whoever wrote the defense standard didn't bother to define application, which is kind of a major stuff up, to be honest, because that's really, really important. So let's go back to a ordinary dictionary definition just to get an idea of what it means. By the way, I've checked through the standard, the one that I was referring to, and it does not explain in the standard what it means by application. Otherwise, I would use that for preference. But if we go back to the dictionary, we say, okay, application, the action of putting something into operation. Okay, yeah, so we're putting something to use, we're implementing it, we're employing it or deploying it maybe, we're utilizing it, we're applying it, we're executing it, we're enacting it, we're carrying it out. We're putting it into operation or putting it into practice. So all useful words that help us to understand. I think we know what we're talking about. So we've got a thing or a service. Well, what are we using it for? Quite obviously, you know, a car is going to be maybe quite safe on the road. Put it in water and it probably isn't safe at all. So it's important to use things in their proper application, or put them to the use to which they were designed. And then, kind of harking back to what I just said, what's the correct operating environment for this system and the application to which we want to put it? So we've got a thing and we want to use it for something. What's the operating environment that will be safe for it? What's it qualified or certified for? What's the performance envelope that it's been designed for? Typically, things work pretty well within the operating environment, within the envelope for which they have been designed. Take them outside of that envelope and they often work not so well, maybe not at all. You know, you take an aeroplane too high, the air is too thin and it becomes uncontrollable. You take it too low and it smashes into the ground. Neither outcome is particularly good for the occupants of the aeroplane or whoever happens to be underneath it when it hits the ground. So all of those three things, what is the system, what are we doing with it, and where are we doing it? All of those things have to be defined. Otherwise, we can't really say that risk has been dealt with or that safety requirements have been met, because these things only work in context. So we've spent several slides just talking about what safe means, which might seem a bit over the top, but I promise you it is not, because having a solid understanding of what we're trying to do is really important in safety, because safe is kind of intangible. So we need to understand what it is we're aiming for. As some Greek bloke said thousands of years ago, if you don't know to which port you are bound, then no wind is favourable. And it's almost impossible to have a satisfactory safety program or safety effort if you don't know what you're trying to achieve. Whereas if you do have a precise understanding of what you're trying to achieve, you've got a reasonably good chance of success. And that's what it's all about. Okay, well, I've quoted you some information from a UK government website, and I've done so in accordance with the terms of its Creative Commons license, and you can see more information about the terms of that at the safetyartisan.com website. You're welcome to go there and take a look. And if you want more, if you want to unpack all the major definitions in the on all the system safety concepts that we're talking about, then there's a longer version of this video which you can get at patreon.com/safetyartisan. So that's my Patreon webpage. I'll say it again, patreon.com/safetyartisan. And I hope you enjoy it. Okay, well, that's it for the short video for now. And as I say, please go and have a look at the longer video to get the full picture. Okay, everyone. Well, it's been a pleasure talking to you, and I hope you found that useful. I'll see you again soon. Goodbye.